Hello aspirants, so welcome back to this channel for another video, and today we will do the continuation of the CBSE Class 11 exercise from NCERT. Okay, every question we will do in detail. Okay, in the last video we have done IUPAC and today we will do two more questions from this. Okay, so what are the things we will do? Without wasting time, we will do this question. So you see the question, this is saying that how do you account for the formation of ethane? Sir, what is ethane? Ethane is CH3, right? Ethane is CH3. Two carbon, this is called ethane. Sir, how do you account for the formation of ethane? So, ethane is forming during chlorination of methane. Sir, what is methane? Methane is CH4. This is methane. So, the first thing that stuck in my eyes or in my head is that both of them are alkane. Both of them are alkane. Now, methane, it's an alkane, and if you are doing chlorination, that means you are doing this reaction. CH4, you are doing reaction Cl2H nu, okay? And I told you that whenever we are doing the reaction in H nu, it is given H nu, that means it's a free radical mechanism. It's a free radical mechanism. Free radical mechanism means the reaction will go and it will form a free radical. Okay, so what is the reaction? It will be ultimately it's a substitution. So one of this H will be substituted by a chlorine. That means the product you will get it will be like this CH3. You see, one of the hydrogen I have eliminated and I have added a chlorine. That means it's a substitution reaction. Then you can further proceed with this reaction. Cl2H nu if you do. Again, remove one hydrogen, add one chlorine. So CH2Cl2. Again, if you do Cl2H nu, again, remove one hydrogen and add one chlorine. And again, remove one hydrogen and add one chlorine. So this is the ultimate reaction. Sir, what is the name? The name of this is methane. The name of this is, you see, it's a methyl group, it's a chlorine, so its name is methyl chloride. What is the name of this? The CH2 group is called methylene, so it's methylene chloride. So what is this? The name of this is, I told you, this is a very important concept, very important compound, and we will do a lot of reaction about this. This is called chloroform. In class 12, we have to do haloform reaction, okay? Haloform reaction. This is very important, okay? And the last one, this is called carbon tetrachloride. Carbon tetrachloride. Okay, sir. But the question is not about this. This is the introduction I have given to. The question is, sir, from methane, when I am doing chlorination, I should get CH3Cl. But with CH3Cl, I am getting CH3CH3 also. The question is, how? Or the question is why? So for that we have to know the mechanism. So let's go and dive into the mechanism. So this is again I told you that this is a free radical mechanism. Why? How it is going? You see, Cl2 I can write ClCl in presence of H nu or UV, right? It will produce Cl dot plus Cl dot. So how? This bonded electron, you take one electron here, you take one electron here. You see, I am using single-headed arrow. For free radical, you have to use single-headed arrow. Okay, so this is step 1. This is step 1. So what is the step 2? Step 2 is, you can write, you take CH4, but you take like this. CH4, you take CH4 like this. CH3H. CH3H. And any of this Cl dot you take, this Cl dot you give here, and this is like this. So CH3 dot plus H3. Okay. Now step 3, what you want? Step 3, what you want? I want that this CH3 dot, what I have produced here, it should react with a Cl dot. It should react with a Cl dot, and if it reacts, I will get my CH3Cl, and that is my desired product. That is my desired product. Okay, but there is a alternative way. There is a alternative way. What is the alternative way? The alternative way is, you see CH3 dot is forming and so many CH3 dots are forming. So that if CH3 dots are forming, CH3 dot, and if it reacts with another CH3 dot, then what happens? Then you will get CH3 bond CH3. That means ethane. So this is the reason why you are getting ethane as a product when you are doing chlorination of methane with Cl2HCl, because you are getting methyl radical. And the methyl radical, if it's react with chlorine radical, you will get your desired product. But if one methyl radical and another methyl radical, they react with each other, they will get ethane. And you cannot restrict this, right? You cannot suppress this reaction, because free radical reaction, any free radical can react with any free radical. Okay, this is free radical reaction. It's a, like, what do I say, chain continuation reaction, like that. Okay, anything can happen. You can, if any free radical is getting another free radical, it will react. You cannot stop it. Okay, that's why ethane you are getting as a side product. So this is question number 1. Okay, then another question from today we will discuss is that for the following compounds, let me just change the color. For the following compounds, write structural formula and IUPAC name of all the possible isomer having the number of double bond and triple bond indicated. Okay, C4H8. So C4H8, you should have 1 double bond. And C5H8, you should have 1 triple bond. So how to tackle this type of question? That C4H8 means it's a double bond. That means it's an alkene, right? I can write this molecule like this way. And again I am telling, don't use the elaborated formula here. Okay, write the bond dash formula. You can write this as carbon. Then you will put a double bond here. Then you will put hydrogen here. Then you will put hydrogen here. You will put hydrogen here. So it will take a lot of time, and there is a chance of error. Like error is also more here. But always use bond dash formula. Okay, always use bond dash formula. So you see, this is my C4H8 I have to do, but I have to put a double bond. I am putting a double bond here. So if I am putting a double bond here, so what is the name of this? Sir, 1, 2, 3, 4. So the name of this is but1N. No problem. But sir, I can do this thing also. I am putting 4 carbon and I am putting a double bond here. Definitely you can do this, no problem. So 1, 2, 3, 4. So the name of this is but2N. But sir, in but2N, there are 2 possibilities, right? Yes, one is cis, another one is trans. These 2 are actually geometrical isomer. I have told you about geometrical isomer in detail, right? Now, then sir, there is any other possibility? Yes, there is a possibility. You take 3 carbon in the straight chain and 1 carbon as a substituent, and you put a double bond here. Sir, then what will be the name of this? 1, 2, 3. 3 carbon in the straight chain and 1 carbon as a substituent. Or you can, like, if you are having any problem, you take this carbon as 3. And this is your substituent. Sir, what is the substituent? Methyl is the substituent. So 2-methyl prop 1N. This is also a possibility. Sir, any other possibilities? No, there is no other possibility. Sir, if I do like this and I put a double bond here, no problem. This is the same as this one. Okay? This is the same as this one. Sir, I'll put 2 carbon and I'll put ethyl group. Anything you can put, but you cannot get any other structure. Okay? So how many structure? So the answer will be 3 excluding stereoisomer. Excluding, or you specifically write, answer will be 3 excluding geometrical isomer. Or if you want to include geometrical isomer, then answer will be 4 including geometrical isomer. Okay, geometrical isomer. So by this way you have to do this. Okay, so let's take this question again and go for option number B. Okay, option number B. So C5H8 1111. Okay, so let's do it. C5H8. So 1, 2, 3, 4, 5. Okay, and I put a triple bond here. I put a triple bond here. Again, this is not this is not a proper structure of a triple bond. Triple bond should be straight line, but it's okay. We can do, no problem. If like this. So sir, 1, 2, 3, 4, 5. So sir, the name of this is pent 1 ine. Yes. Now can I do this like this? 1, 2, 3, 4, 5, and I put a triple bond here. Yes, definitely I can do 1, 2, 3, 4, 5. So the name of this is pent 2 ine. Okay, sir. Then I can do this also 1, 2, 3, 4, 5, and I put a triple bond here also. If you put, then you have to number from this side. It will also be this pent 2 ine only. It will also be pent 2 ine only. You cannot do any other structure with 5 carbon in the straight chain. So you have to now go for 4 carbon in the straight chain and 1 carbon as a substituent. Okay. 1, 2, 3, 4. Sir, I'll put a triple bond here and I put the methyl group here. Can I do it? Definitely. So 1, 2, 3, 4. So the name of this is 2-methyl. Okay, no, sorry, you cannot do this also. You cannot do this also. Why? Because you see, for this carbon, already 1 bond, 2 bond, 3 bond, 4 bond is already you have done. So you cannot put a bond here. Okay. So sir, what I can do? Can I do anything else? Yes, you can do. To put a methyl group here, that you can do. So the name of this is 3-methyl pent 1 ine. Then any other thing I can do? No other thing you can do. You try anything else you want to try. 4 carbon with a methyl here, like this you want to try. This is the same as the first one. You cannot do it. Okay. Then sir, any other thing I can try? Sir, suppose I want a triple bond here. If you want a triple bond here, and if you want a methyl group here, this is also the same as pent 2 ine. So no other thing you can do. So these 3 are the possible structure. Sir, is there any tricks? There is no tricks. No tricks. You have to do it by your own and you have to get your answer. Okay. There is no tricks. So what will be the answer here? The answer here will also be 3 only. Okay. So 3 is the answer here. In the first case also 3 is the answer. Which one I have done here? 3 is the answer. If you do excluding geometrical isomer, 4 will be the answer. If you include stereo isomer. For your board exam, you can give your answer as 3. You will get full marks. No problem with that. Okay. So I hope you understood it. And if you have any further problem, you can let me know. Thank you. Bye.